Hi, this video continues the series of small tutorials on the basics of a Luma-mu, and that's really 101 in the patching, how we should patch the Luma-mu, what different patch points available, how they can be controlled, and so on. Don't expect anything to be complex, so that's very simple, but we have to begin somewhere. So let's take a look on our setup. So there are obviously several patch points. The most important is the trigger. So what button is doing the same as what trigger will be doing when we patch it to the sequencer, like this Quark SQ1, and I will put it to the gate out and do like this. So you see, I can trigger it now. Great. This is, of course, not enough. We will then use other capabilities, and for instance, what I'd like to play with, I will also do pitch, and let's do that on the upper row of the CVA. So again, to this we have to obviously, the way it works right now, I'm sending the CV voltage out. This one sets the offset, so that's why you can hear the playing it at a various pitch. Okay, so now let's do another test with the sample select cable, and that would go to the another CV output here. And what we are going to do here, we'll ask it to play, or force it to play few well, sounds at the different sounds at the different steps. Same applies here, so the potentiometer is still involved in all of these actions, and basically it sets the offset to the voltage that's coming from here. Also a note, the SQ1, it has different voltage ranges that you have to set up through the functions, and it's currently set to the 0 to 8 volts, so it doesn't have a full scale from the 0 to 10 or from -5 to +5. But that obviously limits us how we can and which samples we can control. But since we have the offset, so we can reach the upper samples if we want. Okay, so that would be it. So here we can control the pitch at the different steps for different sounds and play these multiple sounds at the same time. I think that's really interesting. So the clock input, I cannot demonstrate it with this setup because clock requires to be a very high frequency, so like a 10 kilohertz if you want to have a 10 kilohertz sample rate, or 20 kilohertz or 20 kilohertz sample rate. This one obviously will be just sending very well, slow pulses. That's not enough to drive a whole clock. Same we can do with dynamics. Which one we can use? So we can disconnect the pitch and connect it to the dynamics instead. that would be certainly hopefully you will be able to hear the dynamics here. And the reset and pause, I explained that in the introduction. So what these do, the reset can interrupt the sound. So when you play a half of a sound, it can stop playing the other half, so it will be chopped and trimmed. And the pause just put the playback on pause until you remove the trigger from this. So that's also very convenient. That's really it from the patching perspective. Everything is straightforward. Obviously, you can use multiple sequencers. As you can see, I'm using Luma-mu to drive the clock input to this sequencer. That's why I use the play button of this. And I really, in my setup, I found these two working together as a one drum machine, giving me the expansion channels of the what I'm missing here with Luma-mu. And that's a relatively simple setup here. I can do that in other multiple ways. You can also see that I have expert slippers here, and I will demonstrate that in other video how we can use expert slippers to control the Luma-mu in the oscillator mode. So this one I configured to be always on a loop. So as soon as I hit the trigger, there's no way to stop it, unless you press the reset or disconnect the cable, obviously. But I have several waveforms loaded here. They all are perfectly sample aligned, so it has the same number of cycles, and that's why I can cycle through the waveforms. And so that is a like PPG type of the wave playback function that we can achieve using these. And so similarly, we can patch it to the CV and try to play tones and with a sequencer. That is possible to do. So that's what gives you that module with the always loop function. And so finally, in order to make these type of the waveforms yourself, there are several tools available, including commercial tools, that some of them designed for something like running in a serum, and others waveform synthesizers, so that can be adopted here and easily included onto these ROMs as well. With all of that, well, thanks a lot. That's the basic patching setup I wanted to show. Goodbye.